And now we're going to work out how we actually can plot a graph of something like this. So here we have our orbit speed calculator. We've calculated the big table of distance from the centre of the Earth and velocity of an orbiting spacecraft. It would be nice to actually plot a graph of it. This is going to require us to look at plotting, but also to look at things called lists. Now, to plot graphs, we're going to import a graph plotting package. We're going to import one called matplotlib, which is the most common one used. So what we'll do is have the import command up here. So import, it's matplotlib.pyplot. Now that's a mouthful. Whenever we used it, instead of just typing like math.square root, we have to type matplotlib.pyplot. Whatever the command's going to be, which is a pain. So we can use a shorthand, which is to put as and give it an alias. Let's use PLT as an alias. So that imports it and gives us alias to it. So we can then just type PLT dot whatever the name of the command is. So let's shift enter on that. Now this matplotlib plotting package has a program called plot, which plots x versus y, a scatter diagram. But it needs two lists, one list containing all the x values and one list containing all the y values. So we're going to have to learn how we set up lists in Python. Now the way we do lists is first, it's a different sort of variable. Remember a variable like r here or like g over there, that is actually referring to a cell in the computer's memory. So there's a cell which is labelled big G, which has that value in it. Well, you can do something similar for lists. You'll give a list a name, but now the name, instead of referring to just one cell in the computer memory, refers to a whole row of cells in the computer memory containing a whole row of numbers. How do you do that? Well, first of all, you have to tell Python that the name that you've chosen, which can be anything, refers not to a single number but to a list. So let's have something called, I don't know, x values, and use square brackets, open and close square brackets, and that tells Python this is a list but it's currently empty. And now we can do y vals. This is going to be a list that will store all the y values, and once again beginning and ending square brackets. So now when we get there, Python knows that these are going to be lists. And now what we need to do is go into our loop. Inside the loop, every time it goes through the loop and does these commands, we want to store the current value of r and v in these arrays. And we do that using the append method. So what we do is you type the name of the array, the list x vals, and you type dot append, and brackets what we want to put on the end of it, which in this case, as the x-axis, might be r. And then we do y vals dot append, brackets v. And what that's going to do is every time it goes past, it'll take whatever the value of r is at that particular moment and bung it on the end of the x vals list, and similarly add the v to the end of the y vals list. Okay, so let's run that. Shift return. Okay, so it's run, and we can have a look and see what x vals and y vals looks like now. So let's print x vals. Shift enter, and what you can see is x vals is indeed a list with a whole bunch of numbers in it. So it's not just referring to one number, it's got the first, the second, the third, the fourth. And similarly, if we change that to y vals and shift enter for that, we get the list of all the y values. Okay, so that's all working pretty well. What we can now do down in this cell is actually print the things out. So we're going to use the plot command. So remember PLT is shorthand for matplotlib.pyplot, so it's saying it's the plot command from this library. And like all functions, we have to put the x vowels and y vowels. So you plot the x vowels, comma, y vowels. And we're going to need one more thing. We're going to need a format statement which tells it how it wants our plot to look. Now this consists of two things inside quotes, a symbol and a number. The symbol tells you whether you want to plot dots or crosses or lines, and the number tells you what colour. I'm going to plot line, which means a dash, and I'll plot them in blue, let's say, so dash B. Now that generates the plot, but it doesn't do anything with it because you don't quite know what you want to do with it yet. If you want to show it, you do plot.show. It still has two brackets after it, but nothing in between them. All these functions have to have brackets after them, whether they use it or not. Okay, now let's shift enter on this. And there we have a plot with a blue line. And indeed you can see as x goes down, which is further and further from the centre of the Earth, the speed goes down. Now we could change that. We could change the B to, I don't know, R, to change the colour from blue to red. Or we could change it to black with a K. And we could, for example, have circles. Put a 0 there. Oh, not that. Maybe it's an O. Lots of circles, they're too close together to really see them, or lots of dots with a full stop, or lots of pluses. So there's various things. I think the line's probably the prettiest, and let's make it green because I like green, my favourite colour. There we go. Now of course a graph has to have labels on the axes. You're using the graph to communicate something to someone, and unless there's a label telling you what the axes mean, it's meaningless. So in between the plot command and the show command, we can do plot.xLabel, round brackets, and then put, it's a string, in quotes, we can quote that, so that's distance from centre of Earth. And then we can put the y-label command, plot.ylabel orbital speed. Shift enter, and that's much better. Now sometimes you'll want to actually get your picture as a JPEG or a PNG image file so you can put it in a Word document or something like that. Do that, instead of using the show command, you do savefig. And then you say the name of the file you want to save, and the suffix you give on the end of it tells it what sort you want. So let's say we do orbit speed.png, it'll save as a PNG file. So if we shift enter on that one, now we were on the desktop, so somewhere on the desktop we should have that file. Here we go, orbit speed. Nice graph. If you want to make it bigger, you can put comma dot per inch equals, say, 300. And now when we save it, it'll come out much bigger and sharper, more like publication quality. So the key things we've learned here are the use of lists and the use of the plotting.